Fourth grade lesson 6.7 is comparing fractions. This is just continuing on our journey of being able to compare fractions, which one's larger, which one's smaller. Before we learned how to use benchmarks to help us do it quickly. With practice, that does become quick. At first, it's not, but with practice, it becomes quick. And today, we're going to go into how to use common denominators to do that. All right, so our essential question is how can you compare fractions? Let's unlock the problem and see how they guide us to that. Every year, Avery School has a fair. This year, 3 out of 8, 3/8 of the booths had face painting, and 1 out of 4, 1/4 of the booths had sand art. Were there more booths with face painting or sand art? So what they're asking us to do is just to compare which one had more, 3 out of 8 or 1 out of 4. And if we were using benchmarks, we would probably notice right away that both of these are a little less than half. 2/4 would be half, that's a little less. 4/8 would be half, that's a little less. So maybe the benchmarks aren't going to give us a close enough view. And so what do we do when that happens? This is where we're at. Compare 3/8 to 1/4. Here's how we could do it. One way we could do it is using a common denominator. If you back up and think about a couple lessons ago, we worked on common denominators. You manipulate or control those numbers so that you have the same denominator as each other. When two fractions have the same denominator, they have equal sized parts. They're cut up in equal ways. So then you can compare the number of parts, the numerator amount of parts. So if we have 3/8 and 1/4, we can make that 4 become an 8, right? So we can take 1/4 and we can manipulate that. This is probably starting to click into place a little better than the first time you looked at it. How can I make 4 become an 8? Oh, if I multiply it by 2, that becomes an 8. And if I multiply the denominator by 2 and I need to keep it equivalent, then I must multiply the numerator by 2 as well. 1 times 2 is 2. Okay, so now I know that 1/4 is 2/8. Now they did put the model over here for us to compare it, but at this point, if your denominators are the same, you're probably already starting recognizing, okay, once my denominators are the same, let me just compare my numerators. If I get 3 out of those 8 pieces and you get 2 out of those 8 pieces, I got more than you did, right? So that's larger. So you can go ahead and put that right there. 3/8 is what the alligator wants instead of 2/8. They did put the models here. If you need to draw pictures of fractions, there's 8 pieces and there's 3 of them shaded, and there's 8 pieces and there's 2 of them shaded. If your brain still wants you to draw pictures to help make sense of it, then draw the pictures. You won't need to eventually, but until your brain makes sense of it, do your brain a favor and draw those pictures. You'll get it. Your brain just wants a little more time. Give it to them. Okay, then they give us another way we can use a common numerator. I hesitate to show you this one yet, but I'm going to go ahead and show you. If on this first time through you can go, oh, I see exactly what they're doing there, then feel free to use it. If you're like, what are they talking about? My brain's still trying to digest this, then set it on a shelf and don't worry about it. It's not a strategy you need to use yet. It's not a strategy you need to use necessarily at all. This one always can get you through there. But if it makes sense, then it can help quicken things up on occasion. So you can use a common numerator if they have the same numerator. If we have two fractions with the same numerator, they represent the same number of parts. We compare those number of parts. So we're comparing 3/8 and 3/12. Let's take a look at 3/8 and 3/12. All right. We can't say, oh, look at, they're equal. They're not. This is 3 out of 8, and this is 3 out of 12. So they each have 3 pieces. It's just that these pieces are different sizes. Okay. Now, if you are getting the understanding of the fact with your denominators that that's how many people are sharing it, and you use that previous knowledge in your brain that the more people share something, the smaller piece you're getting. If I have a candy bar and I'm sharing with 8 people, I'll get an eighth of it, or a certain amount of it. But if I'm sharing with 12 people, those pieces are even tinier, right? So if you're understanding that concept, that the bigger this number is, that means the more people are trying to share something, so you're getting a tinier bit. Then what we should recognize is if this is cut into 8 pieces and this is cut into 12 pieces, then at least I'm getting a bigger piece here than I am here. And if that's what you recognize, then 3 of those bigger pieces is more than 3 of the littler pieces. So you can use that skill if your numerators are the same. You can look at your denominators and say, wow, how many people are sharing those though? How many people are sharing the pieces? And if there's a lot of people sharing, you're getting a tinier piece. So that's what this is saying here. When two fractions have the same numerator, they represent the same number of parts, but the part sizes are different because of the denominators. You can compare the size of the part sizes, sharing with lots of people, sharing with not as many people. So on this particular another way, they took that 3/8 and 1/4 and said, well, let's get that numerator to be the same. So we had 3/8, and then this is where the 3/12 came from. They said, let's get that numerator to be the same so I can compare them. So 1 times 3 is 3, and 4 times 3 is 12, and that's where this came from. Okay, so can I manipulate it to have a same denominator and then compare my numerators? Yes, that tends to be the way I do it. If I'm going to manipulate the numbers, I'm going to manipulate them to have the same denominator. Can I manipulate them to have the same numerator instead? Yes, I can do that too. But it relies on me understanding this concept completely, that the higher my denominator is means that's a lot of people sharing and it's smaller pieces. So if that makes sense to you, feel free to use that occasionally, or if you see same numerators, use that connection. But ultimately, I would say stick with just getting used to making that common denominator this one way, because that's a skill you're going to need, making common denominators. It's going to be a skill you need to use a lot, so you may as well practice it that way anyway. Here is the visual of 3/8 compared to 3/12. This is split into 8 equal pieces because it's 8. Let's color in 3 of those. Here is the same candy bar split into 12 equal pieces because 12 people have to share it, and there's 3 of those. And you can see that just by a little bit, see these pieces are wider here than that. So this amount is a little more than that amount. You're getting a little more of the candy bar here than you would there. So 3/8 is larger than 3/12. And if 3/12 was representing 1/4, 3/8 is also larger than 1/4 because those are equivalent fractions. So more of the booths were face painting, which is good because people like face painting. Okay, let's practice here. So they want me to compare 3/4 to 1/3. So I want to see which one's bigger, but they're cut differently. They have different denominators, and it's hard to compare them if they have different denominators. So I really would like a common denominator. And we've practiced that, but it's still going to take some practice. Some of you might recognize right away, well, 4 times 3 is 12. 12 is going to be a common denominator. Some of you may still need to see the multiples happen. Remember, we use that tool of a multiple. So I'm going to count by 4, 4, 8, 12, 16. I'm counting by 4 because that is the denominator here. Then I'm going to count by 3, 3, 6, 9, 12. And we see here that the first meeting point that both of those numbers share on their multiples is 12. And so that's the one that I'm going to use as my common denominator. So I'm going to change them so that both of them have a denominator of 12, cut into 12 equal pieces. Okay, well, how can I do that with 3/4, and how can I do that with 1/3? We use that skill we learned on equivalent fractions. I can force that 4 to become a 12 by multiplying it by 3. And if you wanted to use this to help you know what to multiply by, use this. It took 1, 2, 3 times to get there when you counted by 4s. So 4 times 3 equals 12. And to keep it equivalent, whatever I do to my denominator, I must do to my numerator. 3 times 3 is 9. So I have 9/12 for that one. That's the equivalent with a 12 denominator. Let's get the equivalent for 1/3 with a 12 denominator. I want the denominator to be 12. What do I multiply 3 by in order to get to 12? If you know your multiplication facts, you know that 3 times 4 is 12. If you don't, come up here where you listed them out. 1, 2, 3, 4. 3 4 times is 12. So you can use that tool to your advantage. And now whatever I did to my denominator, I must do to my numerator to keep it equivalent. And that's 4/12. Okay, now that they have the same denominator, they're really easy to compare because you just look at their numerators. 9 out of those 12 pieces is a whole lot more than 4 out of those 12 pieces. So 9/12 is larger than 4/12, and that means 3/4 is larger than 1/3 because these were the equivalent fractions here and these were the equivalent fractions there. They're the same amount, just cut differently. They say they want me to explain that reasoning, and for me, I feel like those numbers tell the story. But if we want it in words, I kind of said it already. 9/12 is equivalent. I'm just going to put equiv. Feel free to do the same to 3/4. And 4/12 is equivalent to 1/3. And 9 is more than 4. 9 is more than 4. Once my denominators are the same, they're cut up the same, now I can just compare my numerators. Okay, let's see another. The more time we see these, the easier it becomes. I know it's not easy at first, so just be patient with yourselves. The more we practice it, the easier it becomes. We want to compare 3/5 and 3/8. Now you could use, if you're understanding that one method of just comparing the numerator if they're the same amount of pieces, you could use that skill if this makes sense, because if you're sharing with 5 people, you're getting more than if you're sharing with 8 people. So you could find that answer right away and explain it here. If that's confusing you, don't let it confuse you. Just put it on the shelf. You'll understand that better later. Let's use the skill that we know we have to get used to anyway and get a common denominator, okay? So we have 5 and 8. Let's count by 5 and 8. 5, 10, 15, 20. Let's count by 8. 8, 16, 24, 32. No matches yet, so let me just keep going. By the 5, 25, 30, 35, 40, and then by the 8, 32, and then it's 40. Oh, here it is. That's the first matching point. So I want a denominator that is 40 for both of them. So let's go be that puppet master and convert these fractions into their equivalent version with a 40 denominator. We're going to do the 3/5 changed over to a 40 denominator and the 3/8 changed over to a 40 denominator. Okay, what do I multiply 5 by in order to get to 40? If your math facts are memorized, that number pops directly into your head. If not, count up here. It was 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm multiplying by 8 equals 40. And I do the same to my numerator. 3 times 8. Well, since I have my 8s listed out, 1, 2, 3, 24. Okay. How about 8? What do I multiply 8 times to get 40? You may know that math fact already. If not, count your 8s. 1, 2, 3, 4, 5. 8 times 5. Do the same to your numerator. 3 times 5 is 15. You have the 5s up here. 1, 2, 3. You might have known that in your head. All right, so 3/5 equivalent is 24/40. And 3/8 equivalent with a 40 denominator is 15/40. And now that they are cut the same way, I can see 24 is a lot more than 15. So, ba-bam, like that. 3/5 is greater than 3/8. We use their equivalents, cut the same way, to compare them. Okay, how do I explain that? Okay, same way as before, I'm going to say 3/5 equivalent is 24/40. 3/8 equivalent is 15/40. and 24 is larger. 24 out of 40 parts, right, is larger than 15 out of 40 parts. So there's my explanation there. Okay, hopefully you're starting by now to feel like, oh, I think I'm starting to get this, or I completely get it. But please, if you're not, if you're still like, oh, I'm still really lost on this, don't worry, you'll get it. You'll give yourself some time. It's okay. So let's go ahead and take a look at this one. I have 3/4 and 7/8. I have two different denominators. I would like for them to be the same. So you may recognize that I can force that 4 to become an 8 pretty easily. So that's my common denominator. If you don't recognize that, then doing the step of counting by each of these numbers will get you there. So let's count by 4, 4, 8, 12. Let's count by 8, 8. And then I don't even need to go any further because there it is, 8. So I'm changing 3/4 into a fraction that has 8 as its denominator. And 7/8, I don't have to change anything on 7/8 because it already has an 8 denominator. So I don't have to do anything with that guy now. Just now with 3/4. I want him to have an 8 denominator. 4 times what number gives me 8? If you know your math facts, that popped into your head immediately. If not, I have 4 listed out here already. So it took 1, 2 times 2, 4 2 times to equal 8. And if I do times 2 to my denominator, I must do the same to my numerator. So it is 6/8. And now that my denominators are the same, I just compare my numerators. So in this case, 7 is larger than 6. So 7 out of 8 parts is larger than 6 out of 8 parts, right? So 7/8 is larger than 3/4. These are the same amount. So I just mark it. Alligator goes to the larger number. How do I explain it? Well, the 3/4 equivalent fraction is 6/8, and 6/8 is less than 7/8 because 6 is less than 7. So that's it. That's it for that one. Okay, same thing. 4/5 compared to 2/3, I have different denominators. Can't really compare them if they're cut differently, so let's cut them up the same. You might see what the first common denominator is going to be, or the lowest common denominator is going to be. But if you don't, then count by both of those numbers. We're going to count by 5, 5, 10, 15, 20. We're going to count by 3 for that denominator, 3, 6, 9, 12. No matches yet. 15, there it is. 15 is the first point at which they will meet. So that's the denominator I'm going to force them into. I will have to change 4/5 to get a 15 denominator. And I also need to change 2/3 to get a 15 denominator. No problem. I'm pretty good at that now. So equals how many 15ths? All right, let's do the multiplication. 5 times what number gives me 15? You may know that in your head. If not, I have my 5s listed out here. 1, 2, 3. 5 times 3, 5 3 times, gives me 15. Do the same to your numerator. 4 times 3 is 12. Down here, 3 times what number gives me 15? Again, you might know that in your head. If not, here's your 3's already listed out. May as well use them. 1, 2, 3, 4. 1, 2, 3, 4, 5 got me to 15. So times 5. Do the same to your numerator. That's 10. Now I can compare them. This one was 12/15 and this one was 10/15. And now that they're cut the same way, I can see 12 is more than 10. 12 out of the 15 is more than 10 out of the 15. So there it is. My explanation would be 4/5 equivalent fraction is 12/15, and 2/3 equivalent fraction is 10/15, and 12 is more than 10. Oh, I don't want that written there. It makes it look like that is the fraction. Is more than 10. There we go. Okay, on the next two questions, which would you use to compare 11/12 and 5/6? Would you use a common numerator or a common denominator? Explain why you would choose that. Now, some of you that said, I'm putting that another way, common numerator approach on the shelf, because that wasn't making sense to me. That could be how you explain. I'm using common denominator because that's the one that I'm understanding better. So common denominator would be this one, 11/12 compared to 5/6. And I could make that 6 become a 12 pretty easily. 6, counting by 6, 6, 12, and there's your match. So I can force both of these to have a 12 denominator. This one already does. And this would be times 2 times 2, 10 12s. And now they have the same denominator, so it's easy to see that 11 is more than 10. So it was easy to get a common denominator there. So I would say common denominator is what I chose here, because it was easy to get the same denominator. It was easy to get the same denominator. Can you use simplest form to compare 8/10 to 3/5? Remember, simplest form is reducing the fraction down to its lowest piece. Oh, let's try that. Okay. 8/10. Let's use our skill from a couple lessons ago where we reduce fractions down. You're dividing by the same number to denominator and numerator, a number that divides evenly into both. And since both of these are even numbers, I can divide them by 2. So I will divide by 2 to both the denominator and the numerator and see what I get. 8 divided by 2 is 4. 10 divided by 2 is 5. And looky there, I suddenly have a common denominator that I can compare these to. So yeah, reducing down a fraction, as long as you're keeping it equivalent, if it brings you to having a common denominator, then it makes it easy to compare them. So now 4/5 compared to 3/5, 4 out of 5 is more than 3 out of 5. So yes, as long as I get, so their question is, can you use simplest form, right, to compare 8/10 and 3/5 and explain? Yes, I can, as long as I end up with same denominator, common denominator. I'll just call it denominator. As long as I end up with a common denominator, then I can compare them. I can compare the numerators, the amount of the pieces that you're getting out of the thing cut into 5. So there's the answer to that. Okay, we're on the Sharon show. Let's have a look. Compare 2/5 and 1/10. They are cut differently, so I need to get a denominator that is the same. Use what as our common denominator? You may recognize right away that 10 is what our common denominator is going to be, because 5 can easily be multiplied by something to become a 10. If you're not recognizing those yet, no worries, you're doing just fine. We'll count by 5 and we'll count by 10 and we will see where those match. 5, counting by 5. 5, 10, 15, 20, counting by 10, 10, and I can stop right there because there's my match. And so that's going to be my common denominator, which 1/10 already has, so I don't have to do any manipulation of this. Just this one. What do I multiply 5 by so that it will become a 10 denominator? It took 2 times to get there. 5 times 2 times 2. Oh, that's not where that goes. Sorry. La, 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 la. They want 2/5 here, and then times 2 times 2. 5 times 2 is 10. 2 times 2 is 4. It's 4/10. So if I'm comparing that 4/10, 4/10 to the 1/10, the 4/10 is bigger. 4/10 size parts is bigger than 1/10 size part, and we know that 2/5 is the equivalent to 4/10 over here, right? Also known as 4/10 is bigger. So there we go with that. We got a common denominator. Use 10 as the common denominator. Should have gone there. We got our common denominator, and once we had our common denominator, we compared them, and that made it easy. We compared the numerators. That made it easy. Okay, on this one, they have us using that another way where we get the numerators to be the same. I'm going to walk you through this one the way they do it, but then I'm also going to back up and do a common denominator way too, in case you're just more comfortable with that. We're comparing 6/10 and 3/4. And if you're really getting comfortable with your multiplication facts and your numbers and the patterns and everything, you know that it's pretty easy to make 3 become a 6. 3 times 2 is 6. And it's not as easy to make 4 become a 10. In fact, you can't. So if you saw that, you might say, let me just go that numerator way instead. We're going to find a common numerator. And the common numerator is going to be 6 because 3 times 2 is 6. And I would do 4 times 2 for 8. So we're going to use 6 as our common numerator right here. And we have our 6/10 already. Now we know, they walked us through here 3/4. I multiplied by 2 to both in order to get that numerator to become a 6. And I had to do that same number times the denominator to keep it equivalent. Okay, so now I am comparing 6/10 with 6/8. It's the same amount of pieces. However, the pie is cut differently. In this pie, you have to share with 10 people, and in this pie, you have to share with only 8 people. So if you're only sharing with 8 people, you're going to get a larger slice than if you have to share with 10 people. So 6 of larger pieces is more than 6 of smaller pieces, is how that would look. All right. If that common numerator is still something you're just not ready for yet, that's not a worry. It's okay. Then we will use common denominator. We count by 10 and we count by 4 until we have a match. 10, 20, 30, 40, and then 4, 8, 16. No, that's not right. 12, 16. That's fixie fix. 12, 16, 20, and here we go. 20 is our first meeting point. So we will get those both to become a denominator of 20. So how do I make 10 become 20? I do 10 times 2, right? 10 times 2 is 20. Do the same to the best friend. 6 times 2 is 12. How do I make 4 become a 20? It took 1, 2, 3, 4, 5 times. So I multiply 4 times 5. So I will multiply 3 times 5 as well to keep it equivalent. And 3 times 5 is 15. Now that my denominator is the same, I can see there's more 15 than 12. And I still get the same answer, right? Still got the same answer as the people who said, I'm going to do the common numerator, and they understood it. If you still don't feel comfortable about the common numerator, fine, no problem. Do the common denominator. You're still going to get the correct answer. All right, let's compare these. We have 7/8 compared with 2/8. And looky here, our denominators are already the same. Winna, winna, chicken dinner. We don't have to do much to this. So if these are already cut the same way, then we just compare their numerators. 7 out of the 8 pieces is more than 2 out of the 8 pieces. So that was easy peasy lemon squeezy. All right, let's look at the next one. We have the denominator of 12 and a denominator of 6, and those are not the same denominator. So it's hard for me to say which one is bigger because they're not cut the same. Let's get a common denominator. You may notice right away that 6 times 2 equals 12, so I can easily get a 12 denominator. If you didn't notice that right away, that's not a problem. Count by 12, 12, 24, count by 6, 6, 12, and here it is. Oh, 12. 12 is going to be my common denominator, right? 12 on both of them is our goal. Well, 5/12 already has a denominator of 5/12. I don't have to do any manipulation to that. He's fine. The one I need to change is 6 to make it become a 12. Well, it took 2 times of counting. 6 times 2 is 12. So I would do times 2, and that gave me 12. And if I did that to my denominator, I must do that to my numerator to make sure it stays equivalent. 3 times 2 is 6. And now that these two fractions have the same denominator, that they are cut up in the same way, then I can compare my numerators. If you get 5 out of the 12 pieces and you get 6 out of the 12 pieces, this one's more. 6 is more than 12, or 6 is more than 5. So that is the correct answer there. Let's look at this one. Notice I have common numerators already. So for those of you who are understanding that common numerator concept, I'll explain it. But then those of you who are still lost on that, we'll go the common denominator route. No worries. 4/10 and 4/6. each of these are getting 4 pieces. It's just that these ones are sharing with 10 people, so they have to split that, whatever it is up, candy bar or pie or whatever, into 10 equal pieces. And these only have to share it with 6 people. They're going to cut it up into 6 equal pieces. So their pieces are going to be bigger than theirs because they're not sharing with as many people. So 4 of those larger pieces is going to be more. All right. So if you're understanding common numerator, great, you're done with that. If you're not understanding common numerator, then as practice for common denominator, let's find our common denominator. We're going to count by 10 and we're going to count by 6. So we have 10, 20, 30, 40. We'll stop there. Let's count by 6. 6, 12, 18, 24, 30. There's our first match is 30. So we're going to make a fraction, equivalent fraction, I should say, that has a 30 denominator for both of those fractions. Well, what do I do to 10 to get it to become 30? I multiply by 3, right? 1, 2, 3 times, counted by 10. It took 3 times to get there, so multiply by 3, and we get 30. Multiply by 3 here, same thing to numerator. 4 times 3 is 12. Okay, what do I do to 6 to become 30? I multiply by 5. If you weren't sure of that, count. We counted by them, so it's there. 1, 2, 3, 4, 5. 6 times 5 is 30. So 4 times 5, I have to do the same thing to the numerator as I did to the denominator, right? So 4 times 5 is 20. And now that I have same denominator, all I have to do is look at the numerators and see which one's bigger. 20 is bigger than 12, so there you go. Got the same answer. On number 6, I'm looking at 6 twelfths and 2 fours, and they threw at us another option too. At one point they said we can reduce those. You could if you wanted to. In fact, if you're recognizing when we did benchmark stuff, 6 is half of 12. You start noticing these things in time as your brain adapts to everything. You start noticing these things. 6 is half of 12, so this is technically 1/2. And 2 is half of 4, so this is technically 1/2. So you might notice right away that those are equal. You might not notice that at all right now, and that's okay. Then we use our steps. So 12 and 4 are my denominators. I'm going to, I know I can make 4 become a 12, and if I didn't see that, that's okay. I could simply count by 12, 24. I can count by 4, 4, 8, 12, and hello, there's my first match, and that's what I'm going to use. So I want a 12 denominator here, which he already is, and I want a 12 denominator here. In order to get 4 to become a 12, I had to go 1, 2, 3 times, so I multiplied by 3. And I have to do the same to my numerator to make sure they stay equivalent. 2 times 3 is 6. And look, 6 is equal to 6. So these are equal. If I'd reduced to these, remember simplifying fractions, 6 twelfths, I know that this can divide by 6, and so can that equally. 6 divided by 6 is 1, 12 divided by 6 is 2. And if I'd reduced 2 fourths, both of those divide evenly by 2, and 2 divided by 2 is 1, 4 divided by 2 is 2, and 1/2. So there's all kinds of ways, once you start really getting comfortable with the fractions, there's all kinds of ways to see where those numbers are at. With practice, you'll get it. I think you're ready to go on to the Think Central. If you're not, just let me know and we'll practice a few more out of the book. There's extra practice in there. We can do that in class. Good luck.